Hello and welcome to another LeetCode problem. Today we're going to be doing the problem of non-overlapping intervals. In this problem, you're given an array of intervals where intervals I start, end, and return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So let's take a look at some of these examples. And for intervals, what you're going to want to do pretty much for almost all these problems is you're going to want to sort them. So we're actually going to take a look at these examples with sorted intervals, right? So we're going to have 1, 2. So the first example, 1, 3, 2, 3, and 3, 4. And let's take a look at an overlap. And in this case, if an interval ends with one value and another interval starts with that value and they're the same, then that counts as non-overlapping. In different problems, it's different things, so you're just going to have to read the problem description for that one. But let's take a look. So where do we actually have an overlap? So we have an overlap here, right? So we have an overlap here, and we have an overlap here, but they're saying we can just get rid of this interval, and then we have no overlap. So if we get rid of that interval, then these two don't have an overlap, and now we remove one interval. So that is going to be an answer of 1. Okay, let's take a look at the second example here. Okay, and let's sort it once again. So this one's actually all the same intervals, so we don't need to sort it. Okay. So 1, 2, 1, 2. 1, 2. Okay, so what do we need to do? Well, we need to remove 2 of these, right? Because there's an overlap here and an overlap here, so we need to remove 2 intervals. So let's just say we remove, these 2, and that's our answer, so we remove 2. And now for our last example, we have 1, 2, and we have 2, 3. So clearly there's no overlap here, right? So we can remove none. So let's actually go into how we would do this problem. We're going to have some sorted intervals. Let's just draw out some sorted intervals. Let's assume they're sorted. And then we'll see how we do this. So let's do this first example, but let's add some more intervals into our problem. Just make it a little bit more complicated, right? So let's have our 1, 2. Let's have our 1, 3. Okay, let's add a 2, 3. Let's add a 3, 4. And then let's add maybe like a, what else can we add? Let's add like a 5, 9. Let's add a 6, 8. And that's good. Okay. Let's have all these intervals. They're all going to be sorted, right? We're going to assume sort right in the beginning. So how do we figure out how to do this, right? So actually just go through some intervals. Let's do this in green. How do we want to do this, right? Like what intervals overlap? So what we actually want to do is we want to keep track of one interval, and if an interval overlaps, we want to figure out like which one do we want to get rid of, right? So let's just say we have a starting interval that we don't really actually care for our saved interval. We don't really care where it starts because we're simply going to be comparing where it ends to the other interval. And I'll show you why that is. So let's just say we have an interval that ends with -infinity. We're just going to keep track of the end point. And we're going to simply check for every single interval, is there an overlap and like what we need to do. And then we're going to have a result, let's just call that R over here. It's going to be 0 at first. So we're going to check if there's an overlap with this -infinity. And obviously the way I made this -infinity is there should never be an overlap in the beginning, right? So in the beginning, we're going to check this -infinity. This is going to be the end point of the interval. We're going to compare that to the 1. Is there an overlap? No, there's not. So if there is no overlap, so we're over here, if there is no overlap, we're simply going to replace the endpoint that we had to the new one, right? So we're just going to replace this endpoint with a 2. So this -infinity goes bye-bye, and we're going to put in a 2 here. Okay, now we're comparing to the next interval. Now our saved interval is 2, we're comparing to this. Is there an overlap? So this other interval ends with 2, and this interval starts with 1, so there clearly is an overlap. So if there's an overlap, we definitely have to delete an interval. But which one do we want to delete, right? So if there's an overlap, we're going to add 1 to the result. But which one do we want to delete? So we have an interval that ends with 2. The start point doesn't really matter. But do we want to keep the interval that ends with 2, or do we want the interval that ends with 3? Well, let's think about it. We obviously want to keep the interval that ends with 2 because that's going to reduce our chance for having overlaps in the future, right? We want to minimize our chances of having overlaps. So if we have to pick between one of these two intervals to keep, we're going to want to get rid of the one that ends later, because that is going to give us more chance of overlap. So in that case, because there is an overlap here, right? There's an overlap here, like we're actually at this interval here. Which one do we want to keep? We actually want to keep the 2. So what we're going to do is we're going to keep the 2, and there was an overlap, so we're going to keep this 2, and now we're going to delete an interval. So, and we're going to add 1 to the, so technically we're deleting this interval. We don't need to actually delete it. All we need to do is we need to add 1 to the result saying one of these does need to be deleted. Okay, so now we kept the 2. Now let's go to the next interval. So we're over here. We're checking this interval. And this last interval ends with a 2, and this interval ends with a, this interval starts with a 2. So if this interval ends with a 2, and this interval starts with a 2, there's clearly no overlap between these two, right? Remember, we're only keeping the end point. So this is the end, end. Okay, so between the 2 and a 2, there is no overlap. So if there is no overlap, we don't need to delete anything, but we do need to update our interval now with the last interval that we checked. If there's 2 intervals that don't overlap, we're going to update our endpoint with the last one, right? So if 2 intervals overlap, we're going to want to be greedy and take the smallest end. But if they don't overlap, we don't need to add 1 to the result, but what we do need to do is we need to update the interval end to be the last one. So we're going to update this 2 to be a 3, and we're simply going to keep going. So now we're going to check here, is there an overlap? And so here, there is no overlap, right? Because this ends with a 3, this starts with a 3. So clearly we're good here. So once again, there is no overlap, so we need to update our result. Right? We need to update our end point to be the 4 if there is no overlap. And that makes sense, right? Because if 2 intervals don't overlap, then we're going to be checking the interval on the right to the next interval. But if they do overlap, we're going to be deleting, and then we can figure out which one to delete. If they don't overlap, we don't have a choice. We have to check, like if we have these 2 intervals and we're comparing them, if they don't overlap, we have to take this one as the next thing we're comparing to because we're not deleting anything here. But if we are deleting one of these, then we can pick which one to delete. So then we have a choice. Do we keep this 3 or do we put it in a 4 or whatever? Okay, now we're going to go over here. And we're going to check, is there an overlap between the 4 and the 5? And clearly there isn't, so these don't overlap. So once again, we're going to update this value to be the end point of this interval. So it's going to be a 9. Okay. And now we're going to be over here, right? So just make sure, yes, this seems good to me. Okay. So what we need to do now is we need to actually check, does this overlap? So this 9 and the 6, yes, they do overlap. So we're going to need to delete one of them. So do we want to delete the interval that ends with a 9, or do we want to delete the interval that ends with an 8? First of all, we're going to update this to be a 2, because one of these will have to be deleted. So clearly, like I said, we want to keep the interval that ends with a smaller number, because that's going to minimize our chances for future conflicts. So we're going to keep the 8, because the 8 is going to be smaller than the 9. And so finally, we're out of bounds, and now we have 2. And let's take a look if that makes sense. So we deleted 2 intervals. So we had an overlap here. Remember, we went greedy. So we deleted the interval that's bigger. So we deleted this. And we also had a conflict here, and we also went greedy. And so we deleted the interval that's bigger, so we deleted this. And if you take a look, let's see if it makes sense, right? So we have 1, 2, 2, 3, 3, 4, 6, 8. And that's a perfectly valid interval. So that's going to be our algorithm. Let's write it down one more time, just so we get it. So we're going to start with interval that ends with -infinity. Compare compare our interval to Kerr interval in the intervals. We have 2 cases. If there is no overlap, then let's update our interval to be the Kerr interval end. And then the other case, if there is overlap, let's be greedy, and our interval end will be the smaller end value. Okay, and that's pretty much it. And then finally, every time there is an overlap, so every time there is an overlap, add 1 to the result. And then we simply return the result. So we're going to start with an interval that ends with -infinity just to make sure there is no overlap between. You could also start with this first interval here. Like, that would be a totally valid approach. We could start with this interval, and then you can just look through the rest of your list. That's totally fine. But I'm just going to start with -infinity. We're going to compare our interval to the Kerr interval in the intervals. And if there is no overlap, we're going to update our value, right? Like if we have these two intervals, if our current interval is over here, and sorry, if our saved interval is over here and the current interval we're looking at is over here, if there is no overlap, we have to update our interval to be this one because we're going to be comparing with this one in the future since we didn't delete anything. But if we are deleting, then we want to delete, we want to be greedy. So if we are deleting here, we want to delete the interval with the bigger end value and we want to store the smaller end value to maximize our deletions. Because let's say we deleted this 1, 2 instead, and we kept this 1, 3, then there would be another overlap here, so we would actually have one more overlap. So we always want to keep the one that ends with a smaller number. Okay, so now we have enough to do the code. So we're just going to say, just call it maybe like end or something equals negative infinity, right? Okay, then we're going to result. We're going to set that equal to 0. Then we're going to say for start and end in intervals. So what we need to do, remember, is we need to compare the start to the end to see if there's an overlap. So if start is less than end, let's just make these names better. So this is going to be like current start and current end, right? So if the current start is less than the end that we have saved, that means there's an overlap. So we're going to add 1 to the result, and we're going to update our end value to be the smallest of the two, right? So it's going to be end equals min of end and current end. We're going to be greedy. We're going to take the smaller one. Now, otherwise, we're always going to update our end to be the current end because we never deleted a value, and so that would be our case here, right? So if we didn't delete the value, this would be end, and this would be cur end, essentially. And so we need to update our end to be this value here. But if we did delete, then we're going to pick the minimum of both of these. Okay, and then finally we need to return the result. Yeah. So the reason you don't need to save like the entire interval is you only need the end value. You're only comparing the end value of the interval you have saved. You don't really care about the start, right? When you compare intervals, you're only comparing this end value to this start value, and then you need to update to this end value. So you're never using this value once you actually have your interval done. Okay, so that's why I only have the end instead of the start and the end. All right, let's take a look. Let's see here. Oh, we never sorted, right? Forgot about that. So, sort. Now, let's take a look. Hopefully we don't have any issues. Nice. We have a pretty good solution. Okay. So, let's think about the time and space complexity here. So for the time, we're sorting, so that's already n log n. Now, what are we doing? We're going through the intervals. We're doing a one pass through the intervals, so the actual pass through the intervals is n. So it'll be like n log n plus n, but n log n is bigger. So this is n log n, this is linear time, and so the time is going to be n log n. Now for the space. So sorting doesn't cost us anything. We're sorting in place. We have an n that doesn't cost us anything. We do have one value that we're saving, but essentially this should be an O of 1 solution. Maybe the sorting algorithm takes some kind of space, but assuming, not accounting for that, we don't actually have any other space. We just have this end variable, and we have this res variable, and that's pretty much it. So it's going to be n log n time and O1 space. All right, and that's actually going to be it for this problem. Hopefully you liked this problem. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.